So dear students, we are back with another video, and in this video we are going to continue with what we were doing in our last classes. So basically we were doing derivatives, and in the last class I have taught you for any nonlinear graph, any nonlinear graph or any nonlinear graph, like uh, this one, xy 0 0 1 1 2 4 3 9, this type of graph. 0 1 2 3 4 1 2 3 4 5 6 7 8 9. Okay, so let's locate the points. 0 1 1 2 4 2 4 3 9. So this is y is equals to x square graph. So for this kind of graph, what we have discussed is, we have discussed average slope between 2 points, between 2 points, and that is given by change in y divided by change in x. And secondly, I have given a hint about instantaneous slope. And instantaneous slope is slope at a particular point. Average slope is slope between 2 points. Average slope is basically slope between 2 points. Average slope is calculated between 2 points, and instantaneous slope is calculated at a particular point. For example, the slope at this point 2 will be, okay, so this graph is exactly not in its shape. So y is equals to x square, so I am drawing a vector y is equals to x square graph here. So it is a curve this way. So this is not a perfect curve, so I have roughly plotted this graph, so that's why it's not came in a good shape. So let's this to be the graph of y is equals to x square, and let us take this is point 2, this is point 2 4, this is 11.11, and this is 0 0. So this point is 1 1, and this point is, let us say, 3 9. So what instantaneous slope gives us is, it gives slope at a particular point. For example, slope at this point, or any point, this point, the slope at each point is actually the slope of a line which is tangent at that point. Meaning the slope at particular point is actually slope of the line which is tangent at that point. So slope at particular point means slope of the line which is tangent at that point. So what is tangent? Tangent is a line which touches a single point on the curve. So if we have a curve, if we have a curve this way, okay, I'll make a better curve. So if you have a curve this way, suppose you have located a point this one, and you want to draw a tangent at this point, then you will draw a line which touches just this point on the curve. It do not touches any other point on the curve. So this is the tangent at this point. Now similarly, the tangent at this point will be a line which touches just this point in the curve. Similarly, the tangent at this point will be a line which touches just this point on the curve. So you have infinite tangent to this curve because there are infinite points on this particular curve. There are infinite points in this particular curve. That means you will have a infinite tangent at this particular curve. You can draw tangent at this point also. You can draw tangent at this point. You can draw tangent at this point. You can draw tangent at this point. So instantaneous slope will give me the slope of the tangent at that particular point. Suppose you want to calculate the instantaneous slope at this point, then what you will do is you will calculate the tangent of a slope. Slope is a straight line actually. So you will calculate the tangent, you will calculate the slope of this straight line at this point. If you calculate the slope of this line, then you will get the slope of the point itself. But this line should be tangential to that point. If you want to calculate the slope at this point, then you will draw a tangent at that point, and you will calculate the slope of that particular point. Understood? Okay, so we have understood what is instantaneous slope. So instantaneous slope is the slope of a point, and the slope of a point means the slope of a line which is tangential to that very point. So how to calculate the slope of that tangent? So it is very simple. For example, for a function y is equals to x square, now you will use derivatives. You will use derivatives to calculate the slope at a point or slope of a tangent to that point. So the meaning is same. You can either say this one or say this one. So let us calculate for this function, for the same function y is equals to x square. For the same function y is equals to x square, and 2 4 3 9. Let us assume, okay, let's assume this is 3 9 point, this is 2 4 point, this is 1 1 point, this is 0 0 point. So let's calculate instantaneous slope at 1 1. 1 1 means x value is 1, y value is 1. So you have a function y is equals to x square. So what you will do is you will use derivatives. So I am using derivatives here. So first rule, okay, rules of derivatives will be, so first rule of derivatives will be, suppose you have a function, any function y. Now when you calculate the derivative of this y, then what you will do, let this y is equals to x to the power n. Okay, this y is a function of x, and x has a power of n. So n can be anything. N can be 1 2, n can be anything, 0 1 2 3 and so on. In general, let's x have an n power. N can be anything. So in general I am saying let you have a function y is equals to x to the power n. Now when you calculate the derivatives of this y, then the first rule will be derivative is represented by d dx. D by dx is your derivative. This is how symbolically we write derivatives. So symbolically derivative is represented by d dx. So d dx of, for which function you are calculating the derivative? You are calculating the derivative of this function, y is equals to x to the power n. So that means you are calculating the derivative of y, d dx of y. Or in other word, d dx of, in place of y I can write x to the power n, because y is equals to x to the power n. So d dx of, in place of y you can write x to the power n. So the rule will be d dx of x to the power n will be, d dx of x to the power n will be, see, this n comes, like this n comes in the front, and x will be as it is, and n minus 1. So this is the rule of a derivative. So d dx of x to the power n is actually nxn minus 1. Okay, so this is the first rule. So I'll give you few rules. The second rule will be d dx of, suppose you have a function y is equals to x to the power n, or let us take you have a function y is equals to, okay, I'll come to it later. So first rule is this one. So I'm using first rule out here. So let's calculate the derivative of y is equals to x square using this first rule. So what will be my first rule? My first rule will be d dx of y, but d dx of, in place of y I have, for y is equals to x square, I'll have d dx of x square. Now according to this one, n comes in front, but in place of n I have 2. So 2 comes in front, x as it is, and n minus 1. So in place of n minus 1, in place of n I have 2, n minus 1 will be minus 1. So just replace n by 2, and in place of n it is 2, in place of n it is 2. So it will be 2x, 2 minus 1. 2 minus 1 is just 1. So x to the power 1 can be written as x itself. So it is 2x. That means derivative of y will be 2x. For y is equals to x square. For y is equals to x square, derivative of y will be 2x. Now, what is the value of x? At what x I am finding the derivative? At x is equals to 1. At x is equals to 1, I want to know what is my derivative. So at x is equals to 1, d dx of y, for x is equals to 1, I want to know at what point at x is equals to 1, what is the derivative of y. So at x is equals to 1, this x can be replaced by 1. So 2 into 1, that is 2. That means derivative of y is equals to x square, derivative of y is equals to x square at x is equals to 1 will be 2. That means slope at x is equals to 1, slope at x is equals to 1 will be equals to 2. So for the point x is equals to 1 is this point, x is equals to 1 is this point. For this particular point x is equals to 1, if I draw a straight line tangential to that point, then the slope of this particular point will be 2. So I hope you got it. I'll give you few homeworks. Homeworks for you. Homeworks will be, find the instantaneous